All right, first of all, we're looking at what are called piecewise functions. And why they get their name is from this idea of pieces. If you take a look at this first graph, you got one line here, and then it kind of stops, and then a new one starts. So there's like two pieces. If you look at this one over here, there are three pieces. Look, there's this line, there's this piece, and this piece. Those are called piecewise functions. Now let me just take some of the coloring off here, and we will take a look at how these guys work. So you'll notice down below the function is listed in two pieces, piece 1 and piece 2. Now you have to figure out, which one relates to which one. Here's some of your hints. This says this is the group that where x is greater than 0. Now x is greater than 0 is kind of to the right over here. So that's this guy, everything to the right of 0. This one says it's everything smaller than 0, so it's these x values going this way, so that represents that one. Now what's quite unique here is this little transition that happens here at 0. Notice that one of the points is open and the other point is what's called closed. So in the world of functions, we normally think the vertical line test would cause us trouble here. If I drew a vertical line through these 2 points, we think we hit 2 points. But actually it doesn't. This point it does hit. This one it does not hit because it's an open point. What the open point means is that it is starting there but is not there. So what I mean by that again is that that point is there, but this point says it's everything that is smaller than that, heading in that other direction. A very important thing. And so again, if you said, well, the vertical line test doesn't work here, it actually does, because it misses this point and it hits that one. So everything tends to work out nicely for this. Now what is a little trickier is this business of, these equations down here, like, these three different things. What do they represent? Well, each of those is like their equation. So for instance, if your x values are smaller than -6, that's the group over here, you're going to use this equation. That's the equation of that line. If you're using x values between -6 and 3, including 3, you are this guy. And if you are between 3 and less than or equal to 8, you're going to use this guy. Now maybe just to make this clear, these are easy equations. These mean for all values between 3 and 8, you have a value of 3. See, 3, 3, 3, 3, 3. And this one just means everybody's -1 for that whole stretch. They take a little bit of getting used to, but they're not that bad actually. So one of the things they'll ask us to do is to graph one of these things. And the way you do it is do it in 2 parts. So if you look up here, I'm going to do the first part. And it gives me some clues. It says use the numbers that are greater than 3. Now, for every student I know, that means don't use 3, but I definitely want to use 3, even though it says bigger than 3. I'm going to tell you why. So I'm going to use 3, 4, and 5. When I put in a 3 into my equation 2x, I get, of course, 6, and then I get an 8, and then I get a 10. So what I'm going to do is I'm going to go over to 3, and this isn't going to be pretty because I'm using my stylus here, but 3 and 6, at 3 and 6, I'm going to do an open dot. And then, let's say at 5 and 10, I'm going to do a closed dot. So I draw my line starting from the open dot. Do you see that? I made an open dot and then off in the direction of my other point, because I'm only using numbers that are going bigger than 3. Now why did I use 3 again? Well, because I need a place to start where the open dot is. Now I'm going to go over and I'm going to use numbers that are less than 3 for the other one. Less than or equal to 3. So again, I'm always going to use 3. So let me put in a 3 there. Less than, I might as well put in like a 0. That's probably good enough. So if I put it in, 3 minus 5 is negative 2. 0 minus 5 is negative 5. So I'm going to go to 3 and negative 2, and I'm going to put a solid dot there, and 0, negative 5. I'm also going to put a dot, and I'm going to draw my line out there. Do you see what I'm doing is that I am creating the graph for the one, and then I'm creating the graph for the other one. And the key is that this guy was allowed to have a solid dot, and this one had to have the open dot to be able to make that work. So you just graph the two of them. It works out nicely. The last thing they ask us to do is to evaluate. Now normally that's not that bad. G of negative 7, plug it in, we're done. What makes it a little trickier is that you have to figure out which part of the function involves the negative 7. And I think it's the first one. See how it says the numbers for x have to be smaller than or equal to negative 6? So what that means is I'm going to use negative 2 times negative 7 minus 10. So 14 minus 10, 4 would be the answer. The reason I use the top one is because that's where the function is. Let me show you another one. Let's try this one at negative 1. Now negative 1, let's see, it happens to be between negative 6 and 3. So I'm going to use this function. And this function is a very easy one. It just says all the values in there are negative 1. So that's pretty simple. Let's go to the next one. It says find me the values for g of 3. And I got to figure out where 3 is. Now notice 3 got listed in this one and in this one. But because this one says it is equal to or less than 3, that's the one we're going to use. So that answer is also just negative 1. The last one is at negative 6. Now, negative 6 is also a tricky spot because it is on two different areas. So let's see if we can figure out. Negative 6 would be in this category, isn't it? Because it can be equal to negative 6 or smaller than it. So again, I'm going to go back and use negative 2 times negative 6 minus 10. This is 12 minus 10 is 2. So the evaluating is kind of tricky. It's all about determining which of the pieces to use to obtain the answer.